Hello everyone, welcome to the third session of the Natural Language Engineering Workshop. In this session we're going to talk about low-level text processing. Let's make NLTK accessible throughout the notebook. To that end, you need to import NLTK, import the word tokenize method, as well as download the book version of NLTK as you have done before. Now let us extract text from the web. To do that, we need to import request from URL-lib. We also need to specify a URL. We can use the URL open method from within request to get a response from the URL. Then we can read the response, decode it from UTF-8, and store it in memory in a variable called raw. We'll learn more about decoding in a few minutes. As you can see, the type of the variable raw is string. Therefore, we can use the len method to see how many characters are stored, as well as use slicing to access a substring and print it to the screen. Then you can use all the normal text operations as before. You can use the word tokenize method and tokenize the string into words. We can count the number of tokens in the text. We can get the average length of a token. And you can use slicing to get specific word sequence from the entire text. We can see the results over here. Now let's construct an NLTK text object to enable all the text processing we are used to. This time, let's use a new method called collocations. Collocations are words that occur markedly together in a text. In other words, they occur highly frequently together. Barack Obama is an example of a collocation. You can usually guess the other word if the first word is mentioned in a collocation. Okay, now let's get the collocations from our text. To search the string, we can simply use the find method. It'll return the position of the first occurrence of the string we're looking for. We can also use the reverse find method to search the text from the end to the beginning. It returns the first position that the string occurs in from the end. Most of the content on the web, however, is not raw text. In fact, it's most likely HTML. If you go ahead and retrieve the text just as before, using the request, the URL open method within request, and store the response, you probably get something like this, which includes the text in addition to the HTML codes. To parse it properly, we can use an HTML parser. One such parser exists within the beautiful soup package. Once you parse the HTML and get the text, we can go ahead and tokenize just as before. You can see how clean the text looks like. Then we can go ahead and utilize NLTK just as before. Let's take a look at the concordance of the word virus in the article retrieved. A quick note is that search engines are not a reliable source for extracting text. The reason for that is they're not consistent across time and region to construct linguistic corpora. Let us learn how to process RSS feeds. To do that, you need to install the feed parser package. You can import the feed parser and then parse an RSS feed URL. This is how you can check the number of entries. Now let's grab one of these entries. Let's take a look at all the keys that exist within that entry. These will help us access different attributes of the RSS post. You can use these attributes to grab useful information about the entry, including its title, time of publication, the link, as well as the content. To get the content here, for example, we can use the summary key. Obviously, we can parse it using Beautiful Soup and get the text. We can also tokenize using NLTK or tokenize method. Let's take a look at a few file operations. Obviously, if you attempted opening a file when it doesn't exist, it'll throw an error. You can check if a file exists using the listDir method within the OS package. Dot signifies the present directory. You can open a file, write to it, and then close it. Instead, you could use the with keyword as a context manager. When you open a file, you can get rid of this the carriage return at the end of the lines and bring it to the screen. The NLTK.data.find method can find the file within a directory, even if you don't have the full name of the file. You can open a file and see the number of characters within a file as before. You can see the type of the variable is string. And again, using slicing to access the substring. Now, what if the content on the web was a PDF file? PDF, as opposed to ASCII and HTML, is not human readable. Let's install Message Pack and Slate to be able to extract text from PDF. To extract text from PDF, we need to use the following libraries: urllib, just as before, Slate, which is a wrapper around PDF Miner to turn PDF into text. Also Bytes.io, so that we can write files to memory. This URL is a PDF URL on the web. You can access the URL just as before, store the response, read the response, and store it to memory as a PDF file. Then we can use stale. Then we can use Slate .pdf method to convert the PDF file to text. You can see the results are comprised of relatively clean text. If you'd like to learn more about PDF processing, take a look at this link. This link is also present in your notebook. Character distribution is a significant feature of language. If you can access a character distribution, you can rank the importance of characters, and you can use them to tell languages apart. Let's import some text from the Gutenberg project again. You can use the frequency distribution method again This time we're only using them on the lower characters. We're also only considering the alphabetic characters. We can get the most common characters by using the most common method within the frequency distribution object. In your exercise, you'll see how you can use this to detect languages. By lower characters, I mean to say lowercase characters. Alright. Now, let's do some simple text operations as before. You can see that we can find the position of the word NLP in the text. And you can grab the context of the position. Now if you use the concordance method just as before, you can see it matches one of the concordances. Here are a few string methods for you to take a look at and play with. Unicode is a standard to present and encode text. Text can be encoded in different formats, including UTF-8, Latin, so on and so forth, which can be decoded all to Unicode and then encoded back to the same or different encodings. When you read a file and specify an encoding, it will decode it into Unicode. In Unicode, you can see that the text is well represented. In Unicode, you can see that the text is well presented. For example, you're not finding any bytes. Bytecodes are code points in them. If you encode the text into Unicode Escape, however, you can see all the code points, non-ASCII characters. You can also get the ordinal of a character and turn that as well into its hexadecimal shape. You can use a escape sequence to define a string. You can see that the type is still string. And if we encode it, for example, to UTF-8, it will become bytes. Here you can see the glyph of a character in its Unicode form. You can see the byte sequence and you encode it to UTF-8. You can see its ordinal, code point integer, and you can see its Unicode name. NLTK tokenizer does allow Unicode strings as input and output. Finally, don't forget to solve all the exercises. See you in the next session.